Figure 4.1 show Earth's magnetic field. So this is Earth magnetic field B. Direction normal to aluminum frame. Dimension 60, 85 centimeter. So this is from 60 to 85 dimension. You can find the value of the area A, but make sure this is a centimeter convert to the meter. And number 1, calculate magnetic flux through the frame. If the direction of magnetic field and the frame is this is the direction of the B, and this is the frame, meaning the flux through the aluminum frame is a maximum. So meaning if the question asks you to calculate the flux, is equal to B A cos cos theta, meaning the B is a magnetic field is a 1.8 exponent minus 4, and the area A is come from the dimension. So meaning this is a 60, 85 convert to the meter is 0.6 times 0.85, right? So that this is maximum flux, so meaning this is equal to 1. So you can find the value of the flux here for number 1 is equal to, calculator, 9.18 exponent minus 5 Weber. This is number 1. And number 2, the frame is flipped so that it's parallel to the Earth's magnetic field in 0.2 seconds. Calculate induce. So meaning if the frame flick to the flicks and parallel, so meaning the direction of the flick here flick to the direction parallel to the Earth's magnetic field. So meaning here if the parallel, the flux, if you look at the equation BA cos theta, because theta is angle between B and A. So if the parallel between B and A, meaning the theta is equal to 19. So this is flux final. So initial flux is discussed in the question number 1 is a maximum BA. This is the magnetic flux, 9.18 exponent minus 5. So to calculate the induced EMF, or induced EMF is equal to change of flux divided by time t. So now this is a change of flux here is the initial to the final flux here. So now you have initial flux is the final is equal to 0, okay, minus change of flux. This is final flux minus initial flux is equal to 9.18 exponent minus 5 and divided by in 0.2 seconds. So now you can find the value of the induced EMF is equal to 4.59 exponent minus 4 volt. Right, this is number 2. Continue to next question. Figure 4 shows 0.6 meter long metal bar. Pin pull is to the right at a speed 5.7 meter per second perpendicular to the 0.70 Tesla. And metal ray connected to the 5 resistor. This is a 5 ohm resistor. So now the metal bar is pulled to the right, pulled to the right with a speed 5.7 meter per second, and direction of the bar to the right, and this is direction of the B. If you look at the diagram here, direction of the B is upward from the paper. Okay, so the next is number 1, calculate magnitude of induced EMF. So this is moving conductor in a magnetic field. So number 1, you can use the equation, induced EMF is equal to BLV. So the B is the magnitude of magnetic field, L is the length of the conductor, and the V is the speed of moving conductor. So the B here is equal to 0.7, and the length of the conductor is equal to meter bar 0.6, and the V speed of the metal bar is 5.7. So now you can find the value of induced or magnitude induced EMF is equal to 2.4 volt. And this is number 1. And the next question, number 2, calculates current through the capacitor. So if the magnetic bar, so if the current, if the induced EMF in the metal bar, meaning you can produce induced current. As you know, if you have the induced EMF, meaning you can find that, or you can produce I, or induced current. So now if you have the induced EMF, so you know the I induced in the conductor and connected to the circuit and connected to the resistor 5 ohm. So the question asks you calculate current through the resistor. So you can use the equation from the Ohm's law. V is equal to IR. So V here is refer to the induced EMF in the circuit or in the metal bar, is EMF is equal, this is induced, I current, and the R is a 5 ohm, and induced current is equal to 2.4. And now you can find the value of the current flow is equal to EMF induced divided by R, and the value of the induced EMF is equal to 2.4, and the resistor is equal to 5. So now you can find the value of the current is equal to 0.48 ampere. Okay, and the next is okay, you have another question is direction. So to find the direction of the current or induced current, so to find the direction of the current in the metal bar, so you can use the right hand, because the direction of the, this is external magnetic field, the direction to outward, so meaning to oppose the magnetic field direction, so you must induce B into the page. This is opposite direction of the external B. So this is external B, or this is original B. I say this is BO, and this is B from induced. Okay, so this is B induced by the current I. So now if you use the right hand, the direction of the current flow to produce magnetic field direction into the page, so direction to the downward. Next question, number C. A solenoid of length 8 exponent minus 2 and cross-sectional area 5 exponent minus 5 meters square contain 6,500 turns per meter length. Calculate self-inductance. So now this is how to calculate self-inductance for the solenoid. So the equation here is a nu naught n square times I times A. And the value of the nu naught is constant. This is 4 pi exponent minus 7. And this is the small n here is a number of turns per unit length. So this is equal to 6,500, and the current flow is a 8 exponent. Sorry, this is not I. This is L. Sorry, this is L. Okay, exponent minus 2, and this is A is area. Is given by the question 5 exponent minus 5. So the final answer for the self-inductance in the solenoid is equal to 2.12 exponent minus 4 Henry. Thank you.